In this lesson, we will continue to derive more trigonometric identities from the basic trigonometric identities. Let's get started with the first one. Since we know that sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. Now, if we substitute alpha and beta both as equal angle, if alpha is equal to angle beta and the value for both of them is theta, this means sine theta plus theta will be equal to sine theta cos theta plus cos theta and sine theta. So essentially what it means is sine 2 theta is equal to 2 sine theta into cos theta. So this is called double angle identity for sine 2 theta. We will be using this result many times. So let's highlight this. And the next one for the same reason is since cos of theta alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Therefore, if alpha is equal to beta and the value for both of them is theta, this means that cos of theta plus theta is equal to cos theta into cos theta minus sine theta into sine theta. So cos of theta plus theta will become cos 2 theta, which will be equal to cos square theta minus sine square theta. So this is the second double angle identity for cos 2 theta. But it doesn't stop here. Using the fundamental trigonometric identity, using fundamental trig identity, what was that? That was cos square theta plus sine square theta equal to 1. If we replace value of sine square theta, so this is equal to sine square theta can be written equal to 1 minus cos square theta. So if we call this as number 2, then from 2 we have cos 2 theta equal to cos 2 theta equal to, the first one is cos square theta minus, instead of sine square theta we are going to use 1 minus cos square theta. So this time it would become cos square theta minus 1 plus cos square theta. So this is equal to cos 2 theta equal to 2 cos square theta minus 1. So that is another equivalent result for cos 2 theta. We can equivalently use cos 2 theta is equal to 2 cos square theta minus 1. Also, so let's call this as number 3. Also, if we want to express cos 2 theta in terms of sine, then we can place the value for cos square theta from fundamental trigonometric identity. Also, cos square theta is equal to 1 minus sine square theta. So if we use this result, then from 3 R2 cos 2 theta is equal to cos 2 theta is equal to 2 into 1 minus sine square theta minus 1. So here we can use cos 2 theta equal to 2 minus 2 sine square theta minus 1, or in other words cos 2 theta is equal to 1 minus 2 sine square theta. So these are three different results for cos 2 theta which we use depending upon the need of our question. So this is number 4. From 2, 3 and 4, from 2, 3 and 4, we use identity for cos 2 theta depending upon the need. So all three of them are valid, and as you can see we have derived 3 and 4 from 2. Therefore all three of them can be used for the value of cos 2 theta. Now let's get to tan 2 theta, that is another double angle identity for tan. Since tan alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha into tan beta. So if this time we put alpha equal to beta, and for both of them we put value theta. So let alpha is equal to beta and the value for both of them is theta. This means we have tan theta plus theta equal to tan theta plus tan theta again over 1 minus tan theta into tan theta. So this gives us the identity for tan 2 theta. Tan 2 theta is equal to 2 tan theta over 1 minus tan square theta. So this is another trigonometric identity for tan 2 theta. These are collectively known as double angle trigonometric identities. Let's do a couple of more questions, and the first question in this is that prove to show that sine of a plus sine 2a, sine a plus sine 2a divided by 1 plus cos a plus cos 2a, 1 plus cos a plus cos 2a is equal to tan a. Now we consider left hand side, and then we will simplify, replacing sine 2a and cos 2a with their equivalent trigonometric identities. So left hand side is equal to sine a plus sine 2a, sine 2a divided by 1 plus cos a plus cos 2a. So now we will replace sine a will be written as such, plus sine 2a will be written as 2 sine a cos a divided by 1 plus cos a, and we are going to use cos 2a, its equivalent trigonometric identity. We will be using 2 cos square a minus 1. The reason we are using this instead of 1 minus 2 sine square a or cos square a minus sine square a, because we take a look at the right side where we will need to prove it to tan a, and tan a is equal to sine a over cos a, means that the denominator must preferably will have cos. That's why we converted cos to a in terms of cos, so that whatever cancellations will take place, at least we will have cos in the denominator. So this will give us sine a plus 2 sine a cos a. We can take sine a common, leaving inside 1 plus 2 cos a in the numerator, and in the denominator we have minus 1 and plus 1 are cancelled out, and we have cos a plus 2 cos square a. And now we can take common in the denominator as well, sine a into 1 plus 2 cos a divided by, if we take cos a common, this will be 1 plus 2 cos a, and we can see that this 1 plus 2 cos a is cancelled out, and what we are left with is sine a over cos a, so which is equal to tan theta, and this is exactly what we needed to prove. Now let's take a look on the next question, where we are required to express cos power raised to power 4 theta in terms of cos, but without any power. The power must be 1, and we are allowed to have multiples of theta instead of powers. So let's see how we can do that. So question number 2, since we know that cos 2 theta is equal to 2 cos square theta minus 1, this means we have 2 cos square theta equal to 1 plus cos 2 theta. Here you can see that the right side there is no power, but there is multiple of theta, and that's okay. That's what the requirement of the question is. Now we are going to take square on both sides. Taking square on both sides, we have 2 cos square theta, square on this side equal to 1 plus cos 2 theta and square on this side. On the left side we have 4 cos power 4 theta is equal to 1 plus 2 cos 2 theta plus cos square 2 theta. We have expanded this with a plus b whole square equal to a square plus 2ab plus b square. So now we have 4 cos power 4 theta equal to 1 plus 2 cos 2 theta. Up to this point it's fine, but for cos square 2 theta we are required again to reduce it into multiples of theta, and for this we will have 1 plus cos 4 theta divided by 2 using the same trigonometric identity for double angles. So this will give us 4 cos 4 theta equal to 1 plus, rather let's take the LCM on both sides. So this will be 2 plus 4 cos theta plus 1 plus cos 4 theta divided by 2. That is common LCM. So here we have 4 cos 4 theta equal to 1 plus 2 will be 3. 3 plus 4 cos theta plus cos 4 theta and divided by 2. And now we take this 4 from left side and divide it on the other side. So this will give us cos 4 theta equal to 3 plus 4 cos theta plus cos 4 theta divided by 8. And you can see that there is no power of cos. All what we have is multiples of theta, and that's what the requirement of the question was. And now the next question, that is number 3. We have to prove, to show that sine 3 theta over sine theta, sine 3 theta over sine theta minus cos 3 theta over cos theta is equal to 2. If this is what we want to prove, we will consider left hand side, that is sine 3 theta over sine theta minus cos 3 theta over cos theta. And if we take LCM, that would be sine theta into cos theta, and this will be sine 3 theta into cos theta minus cos 3 theta into sine theta. And if you remember the formula for sine alpha minus beta, this is equal to, so we will be using sine alpha minus beta, which is equal to sine alpha cos beta minus cos alpha sine beta. So if we use this formula, this will be equal to sine of 3 theta minus theta divided by sine theta cos theta, sine theta into cos theta. So this is equal to sine 2 theta divided by sine theta into cos theta, and if we multiply and divide by 2, the denominator also becomes sine 2 theta. So this is equal to 2 sine 2 theta, and the denominator also becomes sine 2 theta, and both of them get cancelled out, leaving behind 2, which is right hand side, and which was required. So this is how we proved this identity. And now the last, I will be leaving this up to you guys. So number 4, it's the same question, just a bit different. So show that cos 3 theta divided by cos theta is plus sine 3 theta over sine theta is equal to 4 cos 2 theta is equal to 4 cos 2 theta.